a distress signal from a ship S is received by two Coast Guard stations A and B located 3.8 miles apart on the same coastline. So here's our coastline, and the distance from A to B is 3.8. From station A, the signal makes an angle of 48 degrees with the coastline. So from the coastline to the ship, the angle that it makes is 48 degrees. And from station B, so here's station B at the bottom, the signal makes an angle of 67 degrees with the coastline. So this right here, this angle is 67 degrees. Find to the nearest tenth of a mile the distance from the ship to the nearer station. Well, this is the distance from station A to the ship. This is the distance from station B to the ship. And we want to try to figure out the distance from the nearer station. Well, how do you know which station is nearer? Well, you can do this one of two ways. You can go about finding each of these sides and seeing which is shorter, or you have a 48-degree angle, you have a 67-degree angle. The shorter side is going to be opposite the smaller angle. So here we have to go about finding this side that I labeled X, and since it's opposite angle A, basically this question is asking you to find lowercase a. So this is a trig word problem, and what we're going to do, if I just kind of clean up the picture, is try to figure out which of the three rules we're going to be using. So first we look to use SOHCAHTOA to see if we have a 90-degree angle. Here we have two angles. We have the 48, we have the 67. We can add them up and then subtract that from 180. So it looks like here angle S by the ship is 65. So here there's no right angle given. Next we look to use the law of sines. In order to use the law of sines, you need to have one matching set. If they give you one matching side angle combo, then you look to use the law of sines. And here, by actually testing to see if we had a 90-degree angle, now we have a matching set. We have angle S and we have side S. So that's going to tell me that this is going to be a question that uses the law of sines. So I want to go about finding side A. So my A's are going to be my half matching set. So my matching set are the S's, my half matching set are the A's, and I'm going about finding side A, so I'm going to write little a over the sine of angle A. That equals little s over the sine of big S. So I'm going to substitute in. I'm going to have little a over the sine of angle A. Well, in the diagram, angle A was 48 degrees. So little a over the sine of 48. That equals little s, so side S, so that's the 3.8, over the sine of angle S, so that's the angle by the ship, and that's 65 degrees. So this is going to turn into the law of sines because we were given a matching set, and we go about solving using the law of sines by cross multiplying. So I have a times the sine of 65 degrees. That equals 3.8 times the sine of 48. So you always cross multiply when you're using the law of sines. And now to solve for a, to get the a by itself, I'm going to divide both sides by the sine of 65 degrees. So in order to figure out the distance from the closer station to the ship, you're going to do on your calculator 3.8 times the sine of 48 over the sine of 65. So here we're going to get as our answer 3.1. This one happens to be miles, but it's going to be to the nearest tenth because it's the side of a triangle, 3.1. Two sides of a triangular lot. So we're going to have a triangle. And it says two sides of the lot form angles of 29 degrees 10 minutes and 33 degrees 20 minutes with the third side. So down here is the third side, and they tell you the third side is 487 feet long. To the nearest dollar, how much will it cost to fence this entire lot? So we want to put a fence around all three sides of this lot. So we want to try to figure out the length of all three sides. And the fencing costs $5.59 per foot. So here we want to try to figure out all three lengths of the triangle, and then we'll figure out how much it's going to cost for the fence once we know all three sides. Now here they didn't give you any letters for your triangle, and my advice is when that happens to make your own letters. So here I'll call the top angle, angle A, the bottom left, angle B, the bottom right, angle C, and here this first part is going to be us figuring out side B and side C, because then once we know side B and side C, we can add those two up plus the 487, and that'll tell us how much total feet of fencing we're going to need. So let's try to go about seeing which of the three trig rules we're going to be using. First, we look to use SOHCAHTOA to see if there's a 90-degree angle, and here they give you two angles. They give you 29 degrees 10 minutes plus 33 degrees 20 minutes. We're going to add them up and subtract from 180 to see what the third angle of the triangle is. So here the third angle of the triangle is 117 degrees and 30 minutes. So SOHCAHTOA we can't use because there's no 90-degree angle. The law of sines you look to use if you're given a matching set of side angles. And it looks like here, because we found my angle A, we do have a matching set. Here we have angle A is 117.30, and here they gave us side A is 487. So here, since we have a matching set, the A's, we're going to look to use the law of sines. If we weren't given a matching set, we would look to use the law of cosines. And remember, the law of cosines, you really look if they give you all three sides, or if they give you two sides and the angle between. Those are the two keys to using the law of cosines. But here, since they gave you a matching set, side A and angle A, we're going to look to use the law of cosines. But this one's going to take us a couple different steps to getting our answer. First, I'm going to go about finding side C. So I'm going to set up, using the law of sines, little c over the sine of big C, and that equals now my matching set, the A's. Little a over the sine of angle A. So I'm going to substitute in. I have little c, that's what I'm solving for, over the sine of angle C. Well, that angle is the 33 degrees 20 minutes. That equals little a, which was that 487, that third side, divided by the sine of angle A, which we figured out from before is 117 degrees and 30 minutes. So here we're going to go about solving using the law of sines, and you do that by cross multiplying. So here we're going to have x times the sine of 117.30. That equals 487 times the sine of 33.20. And now to solve for x, I'm going to divide both sides by the sine of 117 degrees and 30 minutes. So then this is going to give us the length of side C in our diagram. So here side C turns out to be 301.7. So that's going to be the length of that left-hand side of this triangular lot. So I'm going to label that on my diagram for side C. So that's going to be 301.7. Now, in order to figure out how much fencing we need for the entire lot, we now know the bottom is 487. We know the left is 301.7. Now we're going to go about figuring this side on the right. And we can do that in a bunch of different ways. We can again use the law of sines because we have now two matching sets. We have our A's that we used initially, and now we actually have side and angle C as well. So we can go about using the law of sines again, and we could even use the law of cosines, because the law of cosines says if you have two sides and the angle in between. Here we have the 301.7 and the 487, and we have the angle in between is that 2910. So I'm going to show you both different ways. I can either use the law of cosines to solve for side B by doing b squared equals a squared plus c squared minus 2 times a times c times the cosine of b. Remember, this is the law of cosines when you're finding a side, and remember the side that you're solving for has to match the angle that you're using. So here to solve for side B using the law of cosines, I could go b squared equals a squared, so that's going to be the 487 squared, plus c squared, that's going to be the 301.7 squared, minus 2 times a times c, so minus 2 times 487 times 301.7, times the cosine of angle B. Here angle B was 29 degrees 10 minutes. So I can do this on my calculator to figure out side B. Remember, when you use the law of cosines to find a side, you type in directly into your calculator the entire right-hand side, and then you have to square root your answer because you have b squared. So here, if you solved for side B using the law of cosines, you see your answer turns out to be 267.6. A lot of times when you go about finding and answering these triangle word problems, there's multiple ways of going about getting your answer. You could have used the law of cosines to figure out what side B was, or you could have used the law of sines. You were given the matching set as the A's, and since I'm solving for side B, my half matching set will be side and angle B. So I could have went about solving for side B by going little b over the sine of angle B. That equals the matching set, little a, over the sine of angle A. You did not have to solve it two different ways. I'm showing you that you did have options here. Side B is what we're solving for, that's x, over the sine of angle B. Well, in our diagram, angle B was the 29 degrees 10 minutes. So I'm going to have little b over the sine of 29 degrees 10 minutes. That equals side A, which in the diagram was the 487, over the sine of angle A, the sine of 117.30. And if you went about solving for side B using the law of sines, you would have had x times the sine of 117.30. That equals 487 times the sine of 29 degrees 10 minutes. And now to go about solving for x, side B, I'm dividing both sides by the sine of 117.30. And I'll type in this right-hand side directly into my calculator. And here again, it looks like side B turns out to be 267.6. Sometimes when you use one particular method of solution, like the law of cosines, and then if you use a different method of solution, in this case sines, you get slightly different answers. If you see, these decimals kind of differ as you get to more and more decimal places. But that's okay. Sometimes your answer could be different from someone by like a tenth, and that's okay because I just look and see which pattern you use, which rule you use to go about solving. So here, this is now side B. So I'll label that on my diagram. And now what we want to try to do is we want to try to figure out how much it's going to cost for the fencing to be put around this entire triangular lot. So what I'm going to do is I'm going to add up all three sides. I'm going to find the perimeter of that triangle. So on your calculator, you should add the 3017, the 487, and the 267.6 to get the perimeter of the triangular lot. So here the perimeter turns out to be 1056.3. And now the question said, fencing costs $5.59 per foot. Well, the perimeter is 1056.3 feet. So now I'm going to multiply that perimeter by 559. So here to put fencing around the entire lot, it's going to cost $5,904 and cents is 2 decimal places, 72 cents. So here's our answer to the question.